August 31st, 2013. I want to cover a couple of different topics in this video, but they're all related, and you'll see how they tie in. But what we're looking at is an image from March of this year of comet pan-stars. You see Earth in the dot on the right, and your pan-stars is creating a solar flare to the left. This is a brief article about it from March 10th to the 15th. Now, you'll notice that a lot of the mainstream scientists will not connect these comets with the solar flares because they think, or they say, they're dirty snowballs. But this is what pan-stars look like from Earth. If you were in the right location, you had a good camera. A lot of places it was dimmer than this. But this is, I'm going to go back, and this is the archives from the 14th and 15th of March of this year. And this is stereo behind, which is trailing Earth. Now, Earth is in the dot in the tail of that comet. Now, it looks like it's in the tail, but it's not. They're a lot further apart than they appear in this camera. There's your solar flare. And again, this is pan-stars. The nucleus was 1 kilometer or 0.6 miles. Lovejoy is estimated to be up to 4.8, which is 3 miles. So we're about 5 times larger when we're dealing with Ison, excuse me. But now here on the JPL of pan-stars, notice its close approach to the sun is not close at all. It's out inside the just barely inside the orbit of Mercury. Even though it was classified as a sun diver, it is not one of the ones that come right beside the sun. A good bit of difference. It came from under the ecliptic, and there's your, we're looking at March the 10th. That was your close approach time. Now, the close approach of pan-stars to the sun was 28 million miles. Ison is going to be 1.2 million miles. So you see the difference in how close it's going to get, which affects everything. The amount of disintegration, or the amount of change in direction, the things like that. Also, pan-stars dove in out before it got to Jupiter. Now, it dove below the ecliptic. Ison will not dive below the ecliptic till it passes over Mars and dives in real close to the orbit of Earth. I'll show you that. You see how there's the orbit of Mercury where pan-stars came through, and you can see it was close to the sun. It was hard to see. You had to watch it at night, and you could barely see it. Now pan-stars is above us up to today's date. If you will notice, August 31st, and it's very high. If you go to space weather, they still have some of the pictures coming in from Ison, from pan-stars. But now this is Ison. Notice it is not coming in and rotating back out at the orbit of Mercury, and it's coming in over Mars and diving through the ecliptic between the Mercury and Venus, Earth and Venus's orbit. And then you see how much closer it comes to the sun as it comes in there, dives in the ecliptic there instead of back out before Jupiter. So it's dealing with the inner solar system planets much more. And we had the solar flare yesterday. Don't forget about that. But again, pan-stars is 1 kilometer wide. Ison is 4.8 kilometers. Pan-stars will come. It came within 103 million miles of Earth. Ison 92 million. Pan-stars is 28 million miles from the sun, and Ison will come 1.2 million miles. There's your AU there. That if you go in and you convert your astronomical units to kilometers, you'll have the readings that I have. Now, this is a rendition of the sun with a minor prominence. It doesn't have a lot of effect on the magnetopoles of the Earth because we have this protective layer around us. It's kind of like a water balloon the way it flexes under pressure. Now, when you see the solar flares, notice the scale of Earth. Now, Earth is not that close to the sun. They just put this there to give you an idea of how big these flares are. Now, but it lets you know during this X flare, look at the amount of coronal mass ejection that came off. And again, in the video from last night, watch how that energy wave passes across Mars into the path of Ison. Again, there's the Earth for reference. Now here is an X flare that was to the top left, and it looks like a trumpet. Tremendous amount of energy, and we've been very lucky that one of these X-class flares like this has not been directly Earth-facing, especially the strong ones, because it will do grid damage big time. Here's another view of an X-class flare, and you see that signature X as it overloads the X-ray cameras. It is powerful. It happened during the Carrington event. Now, as far as the comets affecting and causing these CMEs, and you saw the the size of Earth. That is a comet that came in a couple of months before Lovejoy. Wasn't as big as Lovejoy, and you see the CME that was related to it. And a CME that is like that, you saw that on the picture compared to Earth. Here, what we're looking at is, again, in the video from last night, we saw the solar flare that caused the quake. You saw these lines of force of the sun whipping out as the Earth travels around the sun like this. And then when you have a solar event, it can compress them and triple the pressure on the Earth's magnetosphere. And there's where you get your quakes. It will compress it just like an egg inside of a water balloon. And when you've got tectonic plates on the Earth, and it definitely will affect them. But now this is a solar flare as a comet NEAT approached the sun. NEAT was a large comet, but that solar flare almost blew it to pieces. It's still out there, but it will actually come in and cut the tails off those comets. Again, here's when the comet gets that close, you have that large ejection, and there's again a approximate size of Earth. Here is on the top of the sun, one of the largest CMEs that you'll see. It was so large the gravity pulled it back down to the sun. Now on this illustration, it's showing a CME blasting off the sun, and the comet is actually not sun diving, it's coming across those lines. Now the tail stream is blowing back because it's blowing against the solar wind. But what happens is the comet is missed by the CME, but the tail is raked off. That will happen. But as the comet came out of that solar flare, that CME, it regained its tail because it's electric. They watched that on one of the satellites. This again is Comet NEAT coming in a few years ago, and the solar flare. It had about 2 or 3 as it got close. Now guys, this is an effect on an object that I did in a video called the Hidden Planet. Now no one's really named if it's a planet, if it's a dwarf star, what is it, who knows. But this is not the same image. This is from 2003. The image that I showed in the Hidden Planet video and in the Dance in the Plaza video was not occurring during a solar event like you see here. In other words, those solar flares that caused I think was part of the response of the curve of this object has dimmed the camera out somewhat. But this object was moving so fast, this is one frame, and coming so close to the satellite, it's the same exact object. Again, it's a little dimmer than the other one. I'm going to show you both to compare. But the solar flares can affect anything. And guys, if you don't believe there's stuff out there that we don't know about, but they've talked about twin stars or hidden planets, we have an object that's been coming through year after year. This is it without the solar flare in the background. This is 6 years later from the image on the right. Notice how much clearer. Notice the stream and the dust particles behind it. But again, these are extremely expensive cameras. You wouldn't be able to see it from Earth because it's moving at the speed of a bullet. I'm going to talk about that more in the next video. Heads up.